All right, welcome back. Hope you have had a nice break. Are there any questions, anything? Okay, so now I will present example about how do you calculate a p-value, and then based on p-value method to draw conclusion about a population. Let's dive in to this example. Suppose it is designed to test the hypothesis that the mean score of students on a national examination is 500 against the alternative hypothesis that it is less than 500. A random sample of 15 students is taken from the population and produce a sample mean score of 475. The standard deviation of the sample is 35. Assume population is normally distributed. So what are we asked to do here? We are asked to calculate the p-value. Once we have this p-value, we compare p-value with the alpha. Alpha is the level of significance. Usually, alpha is 0.05. Other popular values for alpha is 0.01 or 0.1, but most often alpha 0.05. Okay, and we compare p-value with alpha. If p-value is smaller than alpha, we reject null hypothesis. Null hypothesis we denote it as H subscript 0. And if p-value greater alpha, we fail to reject H0. Okay. In this example, what is our H0? H0 always have connection with equal. Okay, so we assume the population mean mu equal to 500. This is our null hypothesis. I use simple mu represent the population mean because hypothesis is always targeting population, not sample. We already know sample mean. Sample mean is 475. We want to get conclusion about population to say if the population is 500 or this is alternative hypothesis, H1. If population mean is smaller than 500. How do I know it is smaller than, not greater than? It is given, see, less than. If it is given greater than, you should use greater than sign. Okay, any questions so far?
Hi, Professor, I have a question here.
Yes.
I think like for the H0 and H1, for this, I think it doesn't include all the situation. I feel like H0 should be less than 500, and then the other one should be greater or equal to 500.
Thank you. I will write down what you said. You said H0 should be smaller than 500. The other one is greater or equal to 500.
Yeah, that's what I think.
Thank you for your input. I will explain why it is wrong for both, but good thinking, okay? You are thinking, okay? First, why H0 is, you said H0 is less than 500. H0, remember this, will never have this smaller sign. What can be used as H0? There are rules. H0, you can use equal sign. H0 you can use greater equal or H0 smaller equal. H0 only use one of these three symbols. That is the hypothesis rule. H0 could be used as equal, greater equal, smaller equal. H0 will never use smaller. Okay, that's why you are wrong. I'm not saying you are wrong. Your statement about H0 is wrong. Okay. So now H1, which symbol can be used as H1? H1 only have three choices, not equal, greater, or smaller. That is the options for H1. See, your choice for H1 is not one of these. 1, 2, 3. This is three choices for H1. Okay, so return back to, so the correct is H0 equal, mu equal to 500. See, is mathematically means equal. Okay, and equal connect with H0. Connect with the H0. And H1 is less than, see, less than 500. H1 less than 500. Thank you for your question. Any other questions? So our task, H0 and H1, one of them is correct. We want to know H0 correct or H1 correct. How do we know? We use the p-value method to calculate the p-value. Okay. And to calculate p-value, you need test statistics. Okay. So test statistic, it is just a formula. We use a t-test. Try to move this. We need a t-test. So the formula for test statistic t equal to sample mean minus population mean divided by sample standard deviation over square root of sample size. That is the formula for test statistics. And then X bar is given 475. Mu is given. See, mu is 500. Okay, we assume mu is 500. We can reject later. It is like in a court situation. A person is innocent until proven otherwise. Okay. And on the bottom denominator, we have S. S is the standard deviation, 35. Over sample square root of sample size, square root of 500. Okay. And this result gave us negative 2.77. So test statistic is negative 2.77. So after we get this, test statistic, how do we find the p-value? How do we find the p-value? Because this is the t-test, to find the p-value, you also need a degree of freedom. By definition, sample size minus 1 is degree of freedom. Okay, I have a sample, oh, no. This sample size not 500. Nobody pointing out my mistake. Sample size is 15. 15 is sample size. Square root of 15. The final answer is correct, negative 2.77. Okay, so sample size 15 minus 1 equal to 14. okay, equal to 40. So we get this test statistic. Now we found the p-value. So what is the p-value? P-value is the area corresponding to test statistic. Draw a diagram, label test statistic, negative 2.77. What is the p-value? The area, the smaller area corresponding to test statistic. This area is a p-value. This area is p-value. And how do I find the p-value in Excel? If you use statistical calculator, you can use I will give you the hint, F3 test, F2 t-test, F1 one sample, you get p-value as well as test statistic. Here I'm using Excel to find the p-value. I'll just erase this number. And in Excel, this is the one-tailed test. So p-value, you type equal t dot dist dot rt. RT represents right-tailed test. Actually, this is left-tailed test. The reason is dist. I do not have a right tail in the no left tail LT in Excel. The Excel only provide either .2t. .2t means two-tailed, but our test is one-tailed test. So I have to choose RT, one-tailed test. And then X is test statistic. Because I choose RT, I know test statistic, I must provide a positive number. And then degree of freedom is 14. Okay. And this gives me exactly p-value, 0.0075. This p-value, 0.0075 is the answer for the p-value. Okay. And I get this p-value because I use this formula, Control C, Control V. So any questions on producing a p-value? Again, if you use the calculator, easy job, F3, F2, F1, you get the result. Okay. So here I'm using Excel to produce the result for p-value. Once you have a p-value, compare this p-value with alpha. Obviously, p-value smaller than alpha. What is alpha? Alpha is given 0.05. If alpha is not given, you assume it is 0.05. So when p-value smaller than alpha, reject H0. Reject H0. So I have questions. Elizabeth, Dan, Christian. Questions?
I think Elizabeth's hand's just been up for a while.
Okay, go ahead, Christian.
Yeah. Why are we using a positive 2.77 instead of a negative?
Thank you, Excel. The question why we use positive instead of negative. The Excel formula do not have dot left. It is either dot right or dot 2t. In my example, this is left tail test. Because it is p-value. P-value, it is Z test, Z. I want to find this area because of the symmetry. Do you agree this area is the same as this area? If you have negative 2.77, you must also have positive 2.77 because of the symmetry of the bell-shaped curve. Okay. When you have the positive 2.77, this area, right tail area, equal to left tail area. Okay, so that I can use Excel.rt, did you see formula, .rt. When you say .rt, you need to provide a positive t-value test statistic. Otherwise, the Excel will give you a wrong information. Look, if I type in negative 2.77, you get the wrong answer. Okay, so it must be positive 2.77.
Okay, perfect. Thank you.
Okay, our objective is to find the area, and we know left tail area equal to right tail area. Thank you for that question. Okay. Any other questions? Okay, we reject H0. When you reject H0, look at here. Means H0 is wrong. We are in favor of H1. Remember, H0, H1, one of them is wrong, the other one is correct. So through p-value method, we know H0 is wrong, H1 is correct. So our final conclusion, the population average is smaller than 500. That is our final conclusion. The population average smaller than 500. Okay. So I hope through this example, you understand the hypothesis process. Usually you will state H0 and H1, and then you compute test statistics. After that, you compute p-value and then compare p-value with alpha. And this conclusion is universal, regardless which test you are doing. Regardless, it is z-test, it is t-test, it is f-test, it is ANOVA test. Regardless, this is a true, universal truth. When p-value smaller than alpha, you reject H0. When p-value greater than alpha, fail to reject H0. And our example shows p-value smaller than alpha. We reject H0 in favor of H1. Finally, we conclude the population average is smaller than 500. Okay. Any questions? All right. So now let's move on next example, correlation coefficient. And in this example, we are going to calculate what is the correlation coefficient for X and for Y, between X and Y. Okay, and you have two methods. One method, use formula. This is the formula. Okay, and based on this formula, you need to calculate X times Y. Okay, and then add all of them together. See, what is X times Y? Means 22 times 27.8. The result is 611.6. Do another X times Y. Next, X 23 times Y, 28.5. The result is 655.5. Keep on going. Okay, and then sigma means add all this together. That is sigma, is this number. And you have to multiply by n equal to 5. Okay, this is the first item. Now the second item said sigma x times sigma y. What is sigma x? You add all the x. This is your sigma x equal to 133. Sigma y means you add all the y together, add all this number together, and this number is sigma y. Okay, use sigma x times sigma y means use 133 times 157.7. That is this item. Okay, so I explained items on the top. Next, I will explain items on the bottom. So let's go over this item. This item said sample size n times sigma x squared. So let me explain what is x squared. X squared is here. When x equal to 22, x squared equal to 22 times 22, 484. When x is 23, x squared is 23 times 23. The result is 529. Keep on going, okay? So you know what is x squared. Sigma x squared means add all x squared together. This number is sigma x squared. Okay, so next item is sigma x then square. We already know what is sigma x. Sigma x is 133. Sigma x means add all x together. Then square it means 133 times 133. This is this part. Okay, so by the same token, you can explain all the items here. That is the formula method to calculate correlation coefficient. Okay, any questions? Using technology, so this is the result. Okay, plug in all the required numbers, you can get the result. The result is positive 0.89. This number is positive, means when you increase x, y also increased. It is, okay, that is positive. And the number is 0.89 means there is a strong relationship between x and y because the maximum number is 1 for linear correlation coefficient. Okay, so that is a formula method to calculate linear correlation coefficient. Any questions before I move on to the Excel? So using Excel, how do you calculate the linear correlation coefficient? I need maybe a few moments, just maybe 1 minute to type in all the, maybe this is y, this is x. To type in those values, 27.8, 28.5, 30, 35, 36.4. So those are the y, x, 23, 26, and then 27.35. So I type in x and y. Using Excel, how do you calculate correlation between x and y? You type in equal CORREL, that is the formula. And then array 1 usually is x, you select x, comma. Next, array 2, select y. Closing bracket, press enter. I'll redo it.
So for the y, I think, Professor, you only select the 6.
You are
didn't
correct.
select
Yes, thank you for your observation. Yeah, y should be arranged. Thank you so much. This time should be okay. So 0.89. Okay, 0.89. So that is the Excel correl function. Okay. So as you can see, using the technology, it is powerful. Imagine you calculate it by hand.
Quick question about the order of the x versus y here. Does it matter if you have column A first or column B first? Can those be reversed, or does it have to be?
Thank you so much. The question was, if I switch X and Y, if I say call real, I put Y first, and then I put X, it will get the same result. So it does not matter the sequence. That answer your question? Doesn't matter you put X first or you put Y first, because correlation explores the relationship between two variables.
Okay, thank you.
Okay, you're welcome. Thanks for your question. Any other questions? All right, so now we know there's a relationship between X and Y. Can we write down an equation between X and Y? Again, we do two methods, one formula, and then two using Excel. Okay, to use the formula to write down equation, you have to calculate the slope, B1. You have to calculate the intercept, B0. Okay, so this is the formula. I explained the items. All those items I explained in this formula here. Okay, make sure you understand what each items represent. And you plug in the related numbers based on this table here. You get slope 0.678. Okay, and then use the B0 formula. You get the intercept 13.505. You have slope, you have intercept. Of course, you can write down an equation y hat equal to B0 plus B1x. Plug in B0 13.5, B1 0.678, you get this equation. Why we use y hat? Because y hat represents predicted y, and y itself is original y, original data set is y. Okay, so there are three y. Actually, there is another y called y bar. Y bar is the average of original data, called y bar. Hope you will distinguish with these three different y, because it is important in forecasting and in regression analysis. So now I'm going to go back to Excel, explain these three different y. What is y? Those numbers are y. Easy, we know what is y. So what is y bar? So I'm going to delete this one. Y bar is the average of y. So equal average of all this y, that is y bar. So you know what is y bar. So now y hat is an equation. Say y hat equal to 13.505 plus 0.678 times x. See, where is my x? This 22 is my x. So how do you calculate y hat? Plug in x value into the equation. You get y hat, not y. When you plug in equation, you get y hat. Okay, and now you copy down this, you get y hat for other y. Hope you know the difference. Y is original data. Y bar is the average of original y. Y hat is the predicted y. For example, if you predict what is a predicted value when x equal to 22, the answer is the predicted value for x equal to 22 is 28.421. Similarly, what is the predicted y for x equal to 23? The answer is the predicted y for x equal to 23 is 29.99099, etc. So those are the y hat is the result of regression. Okay, and now if I ask you what is the predicted value for x equal to 30, you just can, so the answer is 33.845. How do I get 33? Plug in the equation here. Because
There's
I
just a
use
question about the equation there. I noticed as you dragged it down, it took all of the b, like the associated b values. Should it be always going up to the b2 or should it be going b3, etc. as it goes along?
good question. The question is when I drag it down, it is automatically changed from 22 to 23 in next calculation. That is the beauty of the Excel. You see, it goes to B3. And then when I go to next one, oops. When I go to the next one, the X becomes 26, becomes B4. It is automatically go to the next X when I drag it down. Does that answer your question? Okay.
Yeah, sorry, I was looking at C2, so I got confused there.
Yeah, okay. C2 is just the Y bar, the average of Y. So the purpose of this small exercise to demonstrate the difference between 3Y. Y represent original data, Y bar, the average of original data, Y hat predicted Y based on equation. Okay. So that is the formula method. And how do I use Excel to produce this equation? Use Excel to produce this equation. So to use Excel produce this equation, you can create a scatter plot. You can go actually use data and then data analysis. If you do not have data analysis on your Excel, you can go to File, Options, then you click Add-ins. Under Add-in, make sure you have Excel add-in selected. Then you click Go button. After that, click OK. Okay, so that you have data analysis on your Excel. So now I'm going to go to data, oops, not data analysis. Quick regression, click OK. Now you are asked to input Y range. So you have to click here from A1 to A6. As you can see, I included the label, so I check out the label. Okay, so input X range, so select B1 to B6. Again, I include the label. Okay. And then you want to put the output range. Maybe I want to put output here, A9. Then you click OK button. So this is your regression analysis summary output. Where do you find equation? Your equation is based on intercept B0, 13.51, and slope B1, 0.6775. Based on these two numbers, you write down equation Y hat equal to B0 plus B1X. Okay, plug in B0, 0.68 plus 13.516x. That is your equation based on Excel. Okay, any questions?
Sorry, could you just go over again how you got the data? When you use the data analysis tool, what you clicked?
Thank you so much. I will repeat the step, okay? So I'm going to delete all the stuff I have done, the output. So go to data analysis, select regression. Click OK button. Now it is ask you to input Y range. You select from A1 to A6, that is Y. A1 is the label heading, so you check out the labels button. And then input X range, you select B1 to B6. Okay, after that, you specify where do you want to put output. I want to put output starting from A9, so I select. Then you click OK button. You will get the result.
Okay, perfect. That makes sense. Thank
Okay.
you.
Thank you for your question. Other questions?
Hi, Professor, I have a question here. So for
please.
like the test and the exam, do you want us to use, like we can use the Excel to calculate it, or you want us to write down the step by step how we calculate and to get the answer?
Great question. During the test or exam, I do not specify formula method or Excel method. I just ask you question, what is regression equation based on this XY value? You decide you want to use Excel or you want to use formula. Usually, the format of the test is multiple choice question or short answer. I just need one number. For example, what is the linear correlation coefficient for given X, this number, given Y is this number? My question is, what is the linear correlation coefficient? Remember, we get that answer 0.86, something like that. I don't mind if you use Excel or if you use a formula to calculate that number. I just need that number during the test or final exam. Is that clear?
Yeah.
Each student may get a random number. Your X may be different from another student's X. Okay, this minimums the possibility of we promote academic integrity, make sure it is your work, okay? So we use randomized questions. Sometimes we use randomized numbers, okay? So good question. Any other questions?
Yeah, I have just one question.
Sure.
I don't know if it's the same for you, but the output I got from the data analysis on the Excel gives me a formula that's slightly different than the line of best fit with the formula method.
Oh, okay. I haven't checked. This is a BZU 13.51. Formula is 13.51. I got the same. You see formula method 13.505. The Excel gave me 13.51 similar. Okay. And slope B1 formula gave me 0.678. And the Excel gave me 0.678. I got same answer, Excel and formula. Maybe you want to try again or double check the original number. If the one of the original number is not the same as mine, you may produce different result.
Well, I got the same numbers as you in the Excel spreadsheet, but I just don't see how 13.516 rounds to 13.505.
13.516. Oh, I see your point. Yeah. The calculator method is 13.505. The Excel 13.516. You are correct. There is a slight discrepancy. But if you round the number to two decimals, no, they are not the same. Yeah, I'll make sure this will not happen during the test or exam, or I try to ask you to keep the whole number. If you keep the whole number, those two results are the same. Thank you for your observation. Okay.
Okay, awesome.
Yeah. Maybe I want to copy this. Okay, that's fine. Any other questions?
Yeah, I have a question. I'm just wondering when this recording will be posted, and also if you know the format yet for the testing, if it's going to be like multiple choice or fill in the blank.
Sometimes short answer, sometimes.
Short answer, okay.
Yeah.
As in like typing and filling in the blank with words, or just mostly numbers, or?
Maybe sometimes I need to see the step, but most question, I guess, filling in the blank. No, the multiple choice questions, short answer, and filling in the blanks. Those are the types of questions.
Okay, thank you. And when will the recording be posted approximately?
So for example, after today, I will try to, maybe in 1 or 2 days,
Okay, okay,
I'll try to post it by tomorrow, try.
okay, thank you.
Yeah, because it is large file, I need to download first, then I need to upload. The best case scenario, I posted tonight, I'll try. Then if not tonight, maybe tomorrow. Okay, the worst case scenario, after 2 days, so the day after tomorrow, for sure, you will see this, okay? Yeah. Any other questions? All right. So we completed the presentation about chapter 2. In summary, in chapter 2, it is just review of basic statistics. Those basic statistics include the descriptive statistic, okay? Something like the mean, standard deviation. I also give example about inferential statistics, hypothesis test, okay? Calculate test statistic and p-value. One study tip I would give is you study the examples in class again and again and again until you can do these examples by yourself without looking at the solutions. That way, you are more comfortable and confident in carrying out the test or exam questions, because most of the questions are similar. I just change the numbers, change the scenarios, change the context. Okay. So that concludes our lecture for today. Any questions? Before I let you go, I just want to say that you are the most important asset at the campus. Without you, there will be no need for Ryerson University. Thank you again for your participation in this class. I look forward to see you next class. Next class, I will start by review test chapter 2. Then I will present chapter 3. Okay. We do have some time. If you do not have questions, you feel free to go. If you have questions, we do have some time. Feel free to ask questions, but I will click the stop recording button to save some space. So